I said in the previous video that we'll be breaking down physics so that you understand it better. Ohm's law. Ohm's law explains the relationship of current I and voltage V. The voltage here can also be called potential difference. The law states that the current flowing through a metallic conductor or a wire is directly proportional to the potential difference across its terminals, provided temperature and other physical quantities are kept constant. Now, if you listen to the law very well, notice that there is a condition. The condition here is that temperature and other physical quantities such as pressure, they must be kept constant. They must be constant. Now, that means change in temperature will also affect this. Now, from the law I just stated, sorry, let me erase this. From the law I just stated, I is directly proportional to V. Hope you understand. You know the difference between direct proportion and inverse proportion. When they talk of Y, maybe Y varies directly as X, it means that Y is equal to X, but if Y varies inversely as X, you have that Y would be 1 all over X. I believe you must have done that in case you did not know. So know it from now. This one is direct proportion and this one is inverse proportion. All right. So here you are told that I varies directly as V. Now, when you remove this proportionality sign, it means that V all over I is equal to constant. Now, this constant here is seen as resistance. Is the resistance of that conductor, that wire. Let me use that lowest term, that wire. And it depends on the material by which the wire is made of. Remember that we have copper, we have silver, we have aluminum as well. So silver is the best, followed by copper, then aluminum. So now, this constant, like I said earlier, is the resistance of that conductor. So here, V over I is equal to R. V over I is equal to R. Then now from here, you can get anything you are looking for. If you are looking for V here, you can make V the subject of the formula. If you are looking for I, you make I the subject of the formula. Remember, this can as well be written as R equal to V all over I. Now, if you are looking for V, of course, when you make this the subject of the formula, V is equal to IR. If you are looking for I here, I is equal to V all over R. Remember that in order for this to work, the other physical quantities such as temperature must be constant. Now, temperature, how does temperature affect the rate of flow of current in a conductor? Let's look at this scenario. You have electric jug in your house, or you have electric stove in your house. Now, that is supposed to be connected with a cable of let me call it 4 mm square. I use mm square because we are talking of cross-sectional area of that cable. But now, because of the person that maybe did the work for you and the person now maybe is of 1.5, look at these two cables now. They are not the same area. Now, do you know that when current, because the current of that, let's assume that your hot plate is 2000 watts, then you know that V is always constant. Here in Nigeria, we use 220 volts. Now, V is always constant. Now, when you on the electric cooker, at the beginning, you notice that the current will flow very well. Now, if you go closer to the cable now, if you can have access to the cable, I'm not talking of for you to touch the live wire, I'm talking of the insulation material, the rubber that by which the cable is coated with. You notice that if you touch the cable will, as time goes on, will be heated up. Now, the reason is that the cable is not the size of cable that's supposed to carry that amount of current. Now, with time, you notice that the current flowing will not be the same current that was flowing before, because at this point, the temperature is increasing. As the temperature increases, the resistance of the conductor also increases. Temperature varies directly as resistance. Don't worry, I'm going to explain that very well in the next video. We are going to talk about the resistance of a conductor, and I will break it down for your understanding. So if you look at this, you see that if the size of the cable that thing is meant for is used for that work, the appliance will function very well. So this is very important. All right, let's look at this. Okay, here, let's assume that you have V, the voltage there as 4 volts. 4 volts, that's V is equal to 4 volts. And the current that is flowing, now you have a circuit, and 4 volts is applied to the terminal. That is the voltage there. And the current of 2 amperes, remember that current is measured in amperes. Current of 2 amperes is flowing in the circuit. Now, at this point, you look for the resistance being the constant. So you make use of the formula here, since you have the V being the voltage and I being the current. If you make use of the first formula here, let me write up here, I hope you can see that R is equal to V all over I. So here V is given as 4, then I is given as 2. So here you see that R is equal to, remember that the unit of resistance is ohms. So you don't have to forget that, very important. So if you divide this, 2 cancel itself, 1 cancel 4, here 2. Now the resistance here is 2 ohms. Now what will happen if the voltage is double? At this point, the voltage V is now equal to 8. Remember that the voltage is now double to 8. Now, I, what will be the value of I? Now, what we are going to find out now is it true that the current that's flowing through a metallic conductor is proportional to the potential difference across its terminal according to Ohm's law? Then from here you will see, if that is true, remember that there's a condition for this, that the temperature and other physical quantities must be constant. That means here R is constant, R remains the same here as 2. Now let's look at it now. If that is true, you notice that as this one increases from 4 to 8 here, the I here will also do what? Double. Let's see. Now at this point, what are you looking for? You're looking for I. Which of these formula suits this? Now that I is equal to V all over R. So here, since V is given as 8, of course you have your R as 2. 8 divided by 2. Then 2 cancel itself. 1 cancel 8, 4. So the answer here is 4. What is the unit of current? Amperes. Now, can you now see that when the voltage is 2, the current is 2. Now the voltage increases to 8, the current also increases to 4, provided temperature and other physical quantities are constant. Thank you. So for more physics made easy, you have to subscribe, like, share, and follow.